A lot of these proof questions follow the same pattern. Let's take a look at an example. Prove algebraically that the sum of squares of any two consecutive even numbers is always a multiple of 4. So to start off, we need to define an even number in terms of a letter. So for this, I'm going to use 2n, which I'm going to say is an even number. And I can say that 2n is an even number because I've got a 2 here, so any number multiplied by 2 is always going to be even. So my second even number is going to be 2n plus 2, because an even number added to 2 is just going to give you the number next to it. For example, 4 plus 2 is 6. Now all that I need to prove is that squaring these two numbers here is always going to give me a multiple of 4. Let me start off by writing out what I need to do. So 2n squared plus 2n plus 2 squared needs to give me a multiple of 4. So I'm going to start off by expanding the brackets just to see if that makes things a bit clearer. So that's going to give me 4n squared plus 4n squared plus 8n plus 4. And now if I collect the like terms, I'm going to get 8n squared plus 8n plus 4. Now if I look at these numbers, they're all multiples of 4, so I can just factorize out the 4 here, which gives me 2n squared plus 2n plus 1 inside the brackets. And if I look at this 4 here, this tells me that this number is a multiple of 4. And that's basically the proof done, but just to be safe, let's write a quick conclusion. Now because we can factorize out the 4 here, that means if I divide this number by 4, I'm going to get 2n squared plus 2n plus 1, which is always going to be an integer. So I can say that because this number is divisible by 4, it has to be a multiple of 4. So as 4 times 2n squared plus 2n plus 1 is divisible by 4, it is always a multiple of 4. I really hope that makes sense. Thanks for watching. Subscribe for more.